Hey, Alka, good to see you on the call.
Hey Anu, good morning.
Good morning. We usually wait about 3 minutes after the top of the hour.
Sounds good.
It is Friday morning. Oh, Jawad's here. Jawad, I thought you were going to be late. Glad you're on time.
Oh, that wasn't a message from me. That was a message from JP.
Oh, shoot. Oh, my goodness. Oh, I was wondering the message was a little strange because it said, Hi, Jawad. But it would help if I actually read it properly. So. Okay, it's 8:03. We can get started. So my agenda today was to actually go back to a project um, that had been worked on for many years. This is even before I started calling into BAPI's meetings. It was the proof of concept where they worked on creating a PCB version of sort of an equivalent. So basically, to get they had three chips. I think there was a Broadcom, there was an FPGA, and something else, if I recall correct. But JP will show us he's going to be a few minutes late, so when he comes in, he'll show us. And the goal was to create this easy prototyping board at that time. So in theory, if you extend that idea to anybody who has chiplets, can then do some kind of, I like to loosely use the word interrupt testing, using a structure like that. So it started off really well. We actually had a board, which was phenomenal because it meant there was contribution in kind and dollar wise from different companies to make it happen. But I think, Jawad, you know more about this than me. That I think we ran out of some steam on that front.
Well, yeah, so we were trying to do the package POC, and the major challenge was there were some companies who were willing to provide dies that could be used for chiplets, but somehow we never succeeded in receiving that silicon or even its design information. So that was back in 2019, 2020 timeframe. The big idea was that we take the Mara board work that JP and his work stream had done, and we convert it over to from board software development vehicle to an actual package. So now we are in a different stage. Now there are chiplets available, and and there is a need for interoperability, etc. It's just that we need to think through this a little bit more and then try to find resources, because it does require manufacturing and of boards and packages. So landscape is a little bit better now. So that's why I think it's a great topic to revisit.
Yeah, no, I agree. So we're going to have JP give us an idea of what was done, and then we'd like to, discuss what we can do going forward. So he's going to be a few minutes. Last week, I was hoping to go through everyone who would come to the Chiplet Summit and get their thoughts and feedback. And I don't believe we could actually get everybody in that hour. I know Aran, who is here today, was at the summit, and if you have any thoughts, we can wrap up that piece if there's anyone else who's got feedback from the summit or any thoughts that you have. So Aran?
Hey, good morning. I think that hi everyone. I think that we pretty much covered everything. I thought that the Teradyne keynote presentation was very good. It also feels that we are kind of moving from the hype and the need to convince to people are already understand the value proposition and just need to wait for things to happen.
Mm-hmm. That wait is the hardest part, right? Yeah. Any other thoughts, Aran, or we're good?
No, thank you.
Okay. Did I miss anyone else? Oh, Mark.
I did have one. Hey there. I did have one comment though, which is, I heard a few presenters, obviously not in OCP sessions, but in other sessions, describe UCIe as the de facto chiplet standard. That I heard that a few times, and I think we need a marketing plan to bring BAO more back into the forefront of discussion.
Yeah, I heard those very words yesterday from a company we were talking to, actually.
Yeah, thank you. My pleasure.
Elad and Kevin and I were talking to a gentleman from Rebellions who reached out to us, and he also indicated it seemed like UCI was a de facto standard. I have my own thoughts about it, but anyone have anything they feel strongly about how to go, I don't know if we're exactly challenging the UCIe. I feel that it's in a space that it's probably really useful for. It's a space we also play in, but we also play in other spaces too. Any thoughts on that?
So maybe I'll respond before, and then if other people want to as well. But no, I think it needs to be, we need to keep BAO in the discussion, right? I don't think that it's not obviously up to only OCP to decide if there's one or two or multiple standards that succeed in the future. But we do need to make sure that it stays in the discussion. I think that's our responsibility.
That's certainly true, and I think one of the best ways is to hurry up and finish a bunch of wires 2.1 specs, and then we can start to make some noise around that. The fact is there hasn't been a lot of movement on a bunch of wires for a while, right? So we did 2.0, but now we've been talking about 2.1 for a long time. So do we have something new to talk about? I'm putting the challenge back to the community.
So on the 2.1, we've got Kevin, Elad, Cash, and Shahab working on the different pieces. And we're hoping that we can have a spec for those released by, ready by the middle of this year. And so that's exactly what we talked about on the call this Wednesday, about just putting down some timelines for us. And I think between Kevin and Cash, at least, we think that internally for review in about 2 months, and circulate it, and then send it out in July for committee type approvals.
I see. So that would not make it in time for EMEA Summit at the end of April, right?
No,
No,
it's Global Summit in October.
yeah, we're looking at
Well-
Global Summit, Cliff. It's I don't think it's possible this close.
Then I think, it's great to want to keep a bunch of wires in the discussion. Is there something before mid-year that we could talk about, some use cases that someone can share that can be promoted? Something on the Open Chiplet Economy Marketplace that can be promoted and used to promote bunch of wires. Effectively, to keep it in the discussion, we have to have something new and interesting to share. So we're open to doing it. I guess the challenge would be what would be at the right level that we could talk about it that would get noticed.
So Cliff, let me throw a couple of comments into the ring for everyone. So first of all, my position on UCIe is that it's PCI Express for chiplets. So PCI Express is a horrible interface for a bunch of the use cases that they're talking about using UCIe for. For example, IR Labs is talking about a UCIe interface into their optical module. Now, traditionally, that's a SerDes interface into a standard form factor, right? There's no PCI Express involved. So to me, that's nuts, but it's still going on. Second thing is that it's also a matter of availability. Synopsys has UCIe. I mean, just go down the list. Cadence, all the ASIC suppliers that are doing these chips for our customers on the back end have their versions of UCIe. So only one that I'm aware of that is providing a bunch of wires interface is oh shoot, I'm drawing a blank.
Well, I've seen it on your chips. I've seen it being used by D-Matrix.
So D-Matrix has an internal version. They were selling their core, but they're not anymore.
Yeah, Blue Cheetah is the
Blue
version
Cheetah, thank you, Cash.
Blue Cheetah, yeah.
Blue Cheetah,
Yeah.
yes. And so there's that we're going with. I think the way that we handle this is we attack UCIe's weaknesses, which are legion. And the first way to do that from a marketing campaign is through a white paper.
So here's the thing, right? As far as I'm concerned, UCIe is part of the open chiplet economy.
Yeah, agreed.
It has its rightful place. So
does a bunch of wires.
foundation to support a communication where we start attacking UCIe and saying it's not good here, it's not good here, really isn't something that I'd have an easy time supporting. What I'd rather do is say, look at all the use cases where a bunch of wire is being applied. Or the markets, or we have a new version that's tackling these markets. And we know those are markets that UCIe will struggle in.
Yeah.
That would be my preferred and the way that I could take it forward, right? So,
Yeah, sure. And I agree. I agree. You focus on the positives in that situation and just say, hey, here's something to think about from a use case. And we don't probably even mention UCIe at all. Just say, hey, we do this pretty good, but people draw their own conclusions.
right. So, I mean, if the group wants to write a white paper highlighting use cases where a bunch of wires makes more sense from engineering perspective, could back it up with some data, then perhaps we could publicize that. Usually we'd like to have some new technology coming forward, which is why I was asking when 2.1's coming out, and we can make some noise around that and bring a bunch of wires back into the discussion.
Yeah,
So-
I think the 2.1 use cases are also can be quite interesting, right? Because your chip has one, and Shahab's looking at the optical. Maybe that's an angle we should explore a little bit more. And then Kevin's working with the memory version.
Yeah, I was just gonna jump in. We don't have to wait until some magical committee has approved the final I or dot or whatever they have to do, right? I mean, we're gonna have something by April 1st or April 15th that should be shareable, not just among ourselves, but we can start talking about and start getting people's inputs. I think that's kind of our goal, right? So when is the next OCP thing?
So it'd be the 29th and 30th of April, and we would have an analyst pre-brief the week before. And so we were at the point where we've released an early version of the spec for comment. And we can put a stake in the ground that the full spec is expected by mid-year, then we could start to talk about it potentially.
Yeah, no, I think exactly. And the other thing is it should be a living spec anyway. I mean, we want to invite other people to comment on it and participate in it, right? So I think actually we should really make an effort. You know, if we can do something by the first week of April, and then we have a consensus within the, you know, the PHI group that this makes sense, then we should prepare the documentation and whatever, and work with you and your team to say, hey, this is why it's different. It's addressing you know, a new marketplace for, you know, that's not HPC, but it's edge AI, et cetera, right? It's
Right.
adding memory and making that more efficient. It has optimizations for flexibility and including 3D. I mean, we had a discussion about that, right? Internally last, I guess, a couple of days ago. So I think that, yeah, no, I think it's good to have a goal. Let's really, you know, try and focus on that. Kevin, do you want to add? Because your part, I think, is also very exciting, and I think people will be interested in that, right? Is it possible to have something by April from your perspective?
Anything's possible, Con.
Well, I know you said you were super busy, right? So
Of course, we all are. But I committed yesterday that I'm going to get it something. I think, I mean, there's already a draft spec up on our internal Google Docs drive. It's just, will it be in better shape by then? But I think the way, so, you know, at LM, we produce both. We make UCIe PHYs and we make Bow PHYs, and we make proprietary PHYs. We do all three of them. And what I always say publicly is that it's really application driven and architectural choices, but that when we support whatever, you know, the customers want to do. I think the three cases that we talk about often are when there's either asymmetric data flow. Memory is a great example, as are sensors and other things that you're focused on, Kosh. And then, well, UCI has a streaming mode that's kind of a bolt-on, the really PCIe focused, as John said. And Ethernet traffic or optical module traffic is a really good example where Bow works extremely well, and that's why Shahab is got that part in his application focus, and I have memory, and Kosh has the Flexi for a much more flexible, smaller interface. So I think promoting those three applications is the right thing to do in the April timeframe. So yeah, I can support trying to get my part of it to a point where we can point people to it and get continued contributions. The reason I said OCP Global Summit is just going through the white paper process. I think we have to be done by July 1st for OCP to be able to publish something by Global Summit. Just the review process is seemed to be extremely long, Cliff. So that's why we said, you know, we need to be done by middle of the year to publish in time for the summit.
If it's a spec, the review process
It is.
really,
It's a spec versus a white paper. That's why we
Yes.
think it's going to take longer.
Usually-
But again, publishing it, putting it up, everything Kosh said, we make it public for comments and people's inputs in April to try to close by July and submit for the review process in July. That's reasonable, I think.
if you understand the process and you prepare well, you can typically get a spec through in 4 to 6 weeks. I think what's happened in the past is people have not understood the process well, and therefore they've stumbled during it. But given that we're experienced now, you should plan on 4 to 6 weeks for a spec and 4 weeks for a white paper. The difference is the 2-week voting period. It's not required for a spec.
Okay.
For a white
Well,
paper.
I'm not
My bad.
experienced,
My
so
bad. Yeah.
So we do
Um,
our internal goals lined up, which is what we discussed at our Wednesday 9 a.m. call. And luckily for us, both Kash and Kevin are willing to shoot for an April internal deadline. So it should be in pretty good shape even by then. And so it's something we can publicize and start the process as early as we can, Cliff. But I think that's on the agenda.
Let's okay, then let's put a placeholder in the communication plan for OCP EMEA Summit to talk about bunch of wires 2.0 in a bigger way, 2.1, my bad, in a bigger way. And what I would like to not do is just have a press release talking about, you know, this added feature, this added feature, and this added feature. What I'd like to do is have a release that talks about the new use cases that are enabled with examples of them potentially being worked on.
Mhm.
And then the second part of the news release would be on the features that are enabling, the new features that are enabling that new dimension for bunch of wires. And if we do that, then we can achieve potentially bringing bunch of wires back into the discussion mid-year, for mid-year.
Okay, sounds like we've got some targets here.
If I could have,
one of the excuse me, one of the
Okay, Bill.
question is how to put the results into the conferences, just like the one that is coming up at ISSCC. There will be quite a number of papers there, and I think similarly we want to put the case studies, the research into those places.
thank you, Bill.
I'm listening to a conference call. Oh, okay. So, and I may start to talk suddenly. So don't be surprised if I start talking weird stuff all of a sudden. That's because I'm on a call.
David, are you on talking on? Okay, I think David may not be on the right call. Okay, he is messing up. He's on the wrong call.
So, thanks for your comment, Bill, and this is Kevin again. Yeah, ISSCC is going to have some interesting die-to-die papers this year, and we'll be there demonstrating both UCIe and bunch of wires PHYs.
And where's that, Kevin, that you will be?
It's ISSCC is in San Francisco. What is it, the 16th to the 20th?
February 16th to 20th in San Francisco.
All right, so please let's coordinate with Dirk. I know maybe you and I and Kevin or anyone else that's going to be present and showing off anything related to the work at OCP, including bunch of wires. We can do a media push, and we can do something to make it known that you're going to be there and help create some air cover for you.
Sure. We will send you we'll send you what we're doing at each of us at the ISSCC.
Yeah, please do, and then we can put together a campaign to make sure we drive traffic. If I may, I have to jump in 5 minutes, and I think Jawad was suggesting I say 2 words about OCP APAC event. So this may be the first time you're hearing about OCP APAC in Taiwan. We have good news that this year OCP is going to Taiwan rather than South Korea for its APAC event. And it's going to be a larger event, 2 days with an exhibit floor and 2 days of content. And the good news is we've already got a lot of sponsorships pre-sold. And so this is going to go forward. It's August 5th and 6th. And this is the home of Silicon in my mind. So please, everyone, start to think about whether or not you would like to submit a paper. If we have enough paper submitted, we would probably have a half-day track on chiplets in Taiwan, and it would make a lot of sense for us to have it there. We've had a lot of support and help from folks like ASE and William to meet the right people to get this set up. And we are working to court the semiconductor industry to be part of the event.
That's awesome. Spreading the wings.
So Taipei City, early August. Think about that.
Yeah. Yeah.
Warning, it's very hot there and humid.
Thanks, Cliff. Appreciate that. And now we're going to move on to the main topic for today. JP is on the call, and JP has to leave in 10 minutes, I think. So, JP, all yours.
Yeah, hi, Anu. Thank you. So, good morning, everyone. My name is Jayaprakash Balachandran, JP. I work for D-Matrix. So, I've been involved in OCP ODSA for a long time, but not active currently. But Anu and Jawad and I had a conversation that they want to highlight some of the work we did in the past. Something could be relevant. Based on that, we can decide what we could do going forward. Right, that's what I want to do today. So, so I want to. So I think quite some time back, probably 4 or 5 years ago. So we worked on a community project based on OCP when chiplets were coming up. Right, the chiplets were a pretty new concept, and there wasn't anything available in the market. We started off early, and we did a prototype board to showcase or prototype the concepts of chiplets. And but since many of the people in the call may not be aware of what has been done before, so Anu and Jawad asked me to actually showcase this. And let me actually bring up my slide. Yeah, so let me get to the meat of the presentation, and then we can talk through it more for the questions. So do you see my slide?
Yeah.
Okay, excellent. Let me position it correctly. Okay. Okay, and let me put in the slideshow mode so everyone can see it here. So this is what we actually developed, what is called a POC, proof of concept for chiplets, for a chiplet prototyping. And this, so what we developed is a platform called Mara. So the Mara is actually a baseboard which consists of pitchlets. So it's like, so you see there is a big board, the PCA card at the back, and then there are 3 daughter cards, right? So these daughter cards is what we call as a pitchlets. This is analogous to chiplets in silicon. So at the time, like 4 years ago or 5 years ago, there wasn't any chiplets available to us, but we want to develop software, we want to prototype the ideas. So this platform gave the way to do all that, to develop the idea of chiplets. Right, so this is a chiplet on a PCB. We call that as a pitchlets, and there are 3 pitchlets were defined. The one is actually a Broadcom, the chip from Broadcom based on OCP NIC 3.0 that plugs into this platform. And then we have another pitchlet came from Lattice. So this is the Lattice FPGA control FPGA. That's the platform that is very flexible. You can develop multiple circuits with this or logic based on this. And then we also have a very powerful ARM core CPU from NXP, right? So all these devices can seamlessly integrate and they are wired together. And then, so the ARM core CPU connects to an M.2 SSD as well for any database acceleration application. We demonstrated with this concept was really database acceleration applications. I think it was showcased sometime in 2023 OCP or maybe 2022. Right. So this actually gave the way for people to experiment the idea of chiplets, develop software on it, and before they prototype the actual silicon chiplets. Right. So we had a very good collaboration between different companies, Broadcom, Lattice, NXP, Stamend, and Meta. So this effort was very fruitful to develop hardware and software, and we showcased as a community with OCP, we can develop, collaborate across companies and come up with something like this, like an excellent product that useful for the community. Right. So I'll go in a little more details how the wiring is done and what the board is all about to give you a kind of idea. Before I go there, are there any questions or any high level thoughts or questions?
So JP, I know you're short on time, so I want to pick your brain. So if we were to redo something like this today, do you see a solution that could be valuable for industry to do interoperability, for example, for die-to-die interfaces or anything like that?
Sure, Jawad, that's a very good question. So right at the time when we started, there wasn't any chiplets available. We embarked on this concept for software development prototyping. But today, I see the chiplets have come up. A few companies or universities are working on this kind of chiplets idea. But so like you mentioned, Jawad, there isn't any standard industry platform where we can put these chiplets together, test interoperability, or bring up the chiplets. Everybody has got their own proprietary implementations. So that being at a chiplet test chip or anything to do with chiplets, you need really a custom platform. So we could develop something like a generic platform, a socketed platform like this, where different people, let's say BOW 2.0 chiplet, they can bring in two chiplets, connect them together, test the interoperability or verify the functionality. Right. So I don't see any effort in the industry. Every company is working on their own to develop. Everybody has their things. They have chiplets and they develop their own platform, put them together, test them, prototype them. But I think it's useful to have something in the industry where different companies bring their chiplets together, prototype on a common platform defined by industry body like OCP or ODSA, where it's software and hardware are open sourced, and people can focus on only their IP on the chiplets. Right. So definitely, Java, that is definitely doable. This concept can be extended. We already showcase this kind of community development projects is definitely feasible, and this also beneficial for the whole industry as well. Everybody can share the hardware and software and focus on their key valuables instead of everybody reinventing the same platform.
And JP, if I recall correctly, all the hardware, software, firmware collateral, you eventually contributed that to the community and probably is available on GitHub somewhere, right?
Correct. Yeah. So we don't have that available in GitHub yet, but it's available in OCP Google Drives. We can make that available on GitHub.
No, that's fine. So it's available to the community, right?
Absolutely, yeah. For all this, it's available. That whatever software developed on it, right? It's available on the Google Drives. Yeah.
And if you don't mind, let me jump in here. This is Quinn Jacobson.
Oh, hi, Quinn.
Hello. When we originally envisioned this, we envisioned kind of a roadmap of this. So this board, we're using PCIe as the transport layer between the pitchlets. But what we envisioned as the next logical step was if we could build sort of a bridge chiplet that you could put real chiplets onto one of these daughter cards and then just have their interface then converted to something that could run higher power over the board, which would be higher latency, but you could actually test real chiplets in different pairings, just with sort of a performance penalty that you'd have to dial down the latency and bandwidth because they would have to talk to a transcoder that was then a slower physical link. And so we had this vision that you could go from these initial PCIe based pitchlets to real chiplets being tested before you had to go build your custom package.
Right, exactly. Yeah, thank you, Quinn. So by the way, Quinn is one of the architects for this, how we want to wire up this platform. So just want to acknowledge that. So yeah, Quinn, you are right. We were actually went on that path where we first prototype this, and then we can do the real chiplets with some kind of bridging concept. So let me showcase this a little more. So you can see here that these are 3 different sockets, right? And we can actually mix and match pitchlets or chiplets from multiple companies, and we can prototype. The wiring is pretty general, and it's protocol agnostic. And it can, I mean, the way we architected and designed this, it can carry signals 112 gigabits or even more. At the time, I think we were actually looking at 112 gigabits PCIe Gen 5 or Gen 6 type of applications. But this is actually, anyway, the socket is very generic, protocol agnostic, can take in anything. And so this is actually kind of high level architecture, but you have 3 pitchlets and they are wired together. And this is a little more complex. Let me get to this diagram that Quinn was highlighting. Quinn, this is what that you helped to architect this. So we have each pitchlets have got generic slots. Here we have PCIe and then Ethernet, and they all wired in a very rich fashion. They are interconnected together to form different prototyping applications. Right, so so that's what we demonstrated in that Ethernet and PCIe link, but it could be any protocol for that matter. So we have a generic link connecting us to M.2 SSDs. These are high-speed links, and then we also have QSFPs and connecting to the and we also have PCIe link connecting to the host. So, but think of this all very fluid generic interconnect links where you can bring in different chiplets or pitchlets, and that can be wired in a flexible fashion. Yeah, so all this design collaterals are available if anybody wants to actually is interested in this to explore further. But I'll also put up the what we demonstrated in 2023 is to get an idea. Maybe Anu and Jawad, I'll actually get you the slides. We had some slides or demo videos, so that'll also give some new perspectives for anyone who want to explore this further.
JP, you need to please come back with a little bit more time. Because I think there's something important here that we all need to think through.
Yeah, Joanne, this is Alan. Look, I've always liked this, and thanks Quinn for the extra color on the chiplet to PCI bridge. I think that's a fantastic idea. I think the one thing about this always concerned me is it's another development platform that's going nowhere sort of thing. You then have to start again once you get things going. And so if this could end up being production deployed, or at least, once it could end up all the chiplets being gathered in the same platform. So you can go from a bulky prototype to the final sort of chiplet implementation. And there's a sort of a physical path to that. Then that would be the icing on the cake of what you're offering here. And you all know me, I'm a broken record. The OCP HPC actually has 16 E3.S module sockets and one big one big module for the big powerful processors. So my mind is going down the road of if the big sort of backplane module, the HPCM module, had a decent size FPGA with lots of PCI channels on it, and the E3.S modules could be populated like, instead of in the format you've got, but in an E3.S, each of the little chiplets with their PCI converter, and you plug those modules in, so then you've got a backplane FPGA emulation that you're plugging these real chiplets in. And obviously, if you have a bigger chip that's in chiplet form, you can also obviously add the PCI chiplets to that as well. But this then becomes a deployable unit in a bigger compute. So you can actually wire it up to an x86 or a GPU or whatever for a particular application. You can actually run the application rather than this just being sort of all by itself in the corner as a prototype of testing the chiplets. You actually can plug it in the real system. How does that sound? I mean,
I think that sounds pretty exciting. So we need to get to the next level details on that one, how we may be able to bring E3.S into this work. Along the same lines, Alan, so when we were originally doing this work, we were thinking about several derivatives down the line, right? One absolutely is something like what you're describing that allows people to do the development of their applications ahead of time, right?
Right.
The other one was we had this concept of something like a chiplet socket, which will be defined for 5 vendors to use for their test chip development. And then the idea was that we'll create an equivalent of Mara board on a package and make it available to everybody. So by definition, if the 5 vendors are making a test silicon, they could actually use this platform to do something like a interop. That was another one of the ideas. And then there was a third idea, which was we wanted to use these platforms to develop the EDA tools and chiplet design exchange and all of it. And surprisingly,
Go on.
Go
No,
ahead.
absolutely. That sounds great. I mean, obviously, those of you that have listened to what I've been up to, I've been talking about this system being a full-blown emulation platform that you can replace with chiplets. So that all fits into everything you're saying there, Joanne.
Right. And the challenge that we eventually really ran into, we had all these great ideas. We cannot fabricate anything until there is some material support available.
Right. Well, so with Arvind's presentation last week, I know Arvind's obviously doing everything himself internally, and I don't know how much he would be prepared to share on the chiplet front. But even if we could get him to build his prototyping platform in this format, again, I believe the only way we're going to succeed is to get an organic, step-by-step process towards this. And it needs to feed into people that are developing chiplets. It gives them an easy path for them to test and bring up and emulate their chiplets with other things. And so you need to think about the whole thing and think about it from an organic bootstrapping approach, albeit expensive bootstrapping, but compared to doing everything yourself at the chiplet level, bootstrapping of 50 or 100 million is buttons compared to doing it entirely yourself for billions, I guess, or whatever the numbers are.
Yes, I 100% agree. I think the challenge is who is the anchor to sort of drive this, because it is to build this infrastructure requires capital.
Right.
And we need someone who will, I think some of us had hoped that, this would fall into the CHIPS Act or the other things where we could find some real sponsorship.
Well, so on that, obviously, we've got the Berkeley effort, John Schaff. We've had independent discussions about what was it, the Fugaku machine is open source, so build it like that. We've got all of these point things that people have been talking about without thinking about it holistically. And I'd like to. I think I'm trying to think about it holistically. We've in OCP HPC we've applied for New Frontiers funding at Oak Ridge National Labs, DOE money. We haven't heard anything at all. I don't know if we're going to get any money. I tried to bring IBM into it actually in the past, but yeah, I think that's one of the problems with government money is you need a big guy to sort of say that the government's used to that says we think this is a good idea and we're prepared to work on it together. So I think if you look at as groups, the Chiplets have been working with John Schaff and UC Berkeley and all of that, and the CHIPS Act with, in fact, obviously BAPI. I've been doing it more on the system architect, the high performance computing world, and I've been trying to get people interested in my end from a government perspective. So I've got my various contacts, which are not as strong for sure. But yeah, I think if we can coordinate together, and to be honest, Arvind, I think IBM is a name that is used to working really closely with the government, and I've been trying to work this through Open Power. The president of Open Power is Meow, and so I've been talking to Meow about this as well, right? So, I mean, if we could fold you into that Open Power piece, your research, and bring it all together with OCP, I think we have a powerful, open, independent story to the big guys. Just sort of driving it their way and not really caring about standardization for the rest of us.
Yeah, I think this is all well and good. I mean, in the Phi group, we've been talking about interoperability between chiplets, right? And even with the same standard, if you create a reusable chiplet or you want to have a reusable chiplet, there are a lot of barriers to doing it, right? And that was one of the things that we were discussing with the Rebellions folks was how do you build an ecosystem? How does it work? And the standards are not suitable for that right now. And I think this is actually something we're going to talk about in the business group at 9 o'clock a little bit too. Just say, hey, how can we kick off something which is, you want a chiplet I think Elad expresses this really well. He said that if you have a known system and you're disaggregating, right? So you split it up, which is traditionally the way people are implementing chiplets. It's much easier, right? And that's kind of the way the money is going. That's what people are doing. And you define what you're using on both sides, et cetera. Now, if you look at your aggregating, where you're going to try and put multiple chiplets that have already been done and hook them together, there's a whole bunch of issues, right? From where are they physically to, as you know, with advanced packaging, the reaches are going, a millimeter or less. There's 3D coming. There's the whole thing is very, very different. So, I don't want to put cold water on the kumbaya moment, but there's two issues, right? There's the big picture when everybody's talking about like UCIe is the standard. Well, the logical question is which UCIe? Is it the standard version? Is it the current advanced version? Then there's the UCI 3D. And I bet you there'll be more, right? So, and they're all incompatible. And even if you're compatible with UCIe advanced, I'm just using the UCI as an example, two vendors, when they build chiplets, because of the knock and how they're sending the data, how they are bringing things up, how they're managing it, they're not going to, two chiplets with the same PHY are not going to talk to each other.
Yeah, no, I get it. I
No,
don't
no,
disagree.
this is a big this is the big problem, right?
Yeah.
Frankly, right? It's not wave the UCI flag or wave the bunch of wires flag. There's a real problem in the industry, and I think that's something that at least bears some not in this environment, but I think we need to start thinking about that, right? And if you want to build something like that, then there's going to be a cost to this, right? Because whether it's you need more pins or you need a little bit more power, I mean, I don't know what the cost is going to be, but there's always a cost, right? But as the open chiplet economy evolves or tries to evolve, the standards are probably going to need to change so that you have some framework and say, hey, if you want to say you're an open chiplet, you need to at least do this somehow, or we suggest you do this. And those frameworks may be different for an IoT application to a HPC application. I'm or a multi-cluster of compute application, right? So I think this is where, it's complex.
So, Cash, I think your points are all really good and valid. So we as a collective group of thinkers, we need to figure out solutions because the problem is very clear, right, that you mentioned. So the big idea in doing these standardized harnesses or test jigs was really to help the industry at least do some level of plug fest. And I know that no amount of plug fest guarantees that it will always work, but at least there is something in terms of real testing of two pieces of silicon. And we saw a little bit of that when there was interop testing going on between Blue Cheetah and D-Matrix and then Synopsys and Intel, right? So those are pretty much the only two incarnations that we have. Is there something we can define under a group such as like what JP did, where we can help with interoperability? And maybe it is different for different applications.
Yeah, so if you took a careful look at what D-Matrix and Blue Cheetah did, and also Intel and Synopsys did, they verified that the PHY, you could send ones and zeros over, right? It didn't verify anything about system level interoperability of sending real data or how do you send memory. I mean, it was totally beyond the scope, right? And that's where the real challenge is.
So Cash, can I make a suggestion? Because I completely agree with everything you're saying. But the reality is we need to make, as I keep saying, an organic step-by-step approach to this, a bootstrapping approach. The problem we've got, quite frankly, and I would say with probably everybody in the meeting, is whatever we're doing, we all say, that's our IP. We don't want to give that away. And so, for instance, Cash, what you're doing, you're trying to get a system approach with your view of the world of chiplets. And I don't know how whether you succeeded in your funding or the rest of it, but if we could do that prototype platform that could go to deployment and with this bootstrapping approach, like I'm saying, it'd be great if Arvind could do it at IBM, but I know IBM are quite protective over all their ideas. So if you said, well, I want to get this going because I know if I get it going successfully in an open ecosystem, people that can make use of my version of a chiplet interface will start to use it because it's a much lower cost of entry. And obviously the UCIe is an impossible barrier for small companies to adopt. You've got to think like TTL back in the 80s, 70s and 80s. So if your business had its funding, I don't know where you are in your business, and you were actually building your own suite of chiplets with maybe one or two partners, and you said, well, let's do this in this format. Let's all get together. Then you've sorted out the PHY, you've sorted out the link layer, you've sorted out the system layer. everything communicates, but you build it in this sort of ecosystem fashion that we're all talking about right now, then it's going to be easy for another little chiplet company to say, oh, I'm going to use Cash's interface, which only plays into your hand because you've created the community. And the rest of us want to help you. I want to help you. I don't get paid anything for doing my OCP HPC. You know, I don't intend to. It's only sort of a fun thing for me. A lot of it, obviously, I get contract work. But
yeah, no, I get it. I think that my hope is at least that we can get within the OCP Phi group. I mean, there are 3 active companies right now, right? There's us, there's Blue Cheetah, and there's Elion, right? At least we will. I mean, I think we need to have more of a sit down at some point and just say, hey, what could we do to help this problem, and how can we do this?
Right.
So
we have a community here for many years. We're all good friends that have the same challenges and have the same desires.
Right.
And so it's incumbent upon us to make it happen, right?
Right.
But we do have to come together at some point and say, this community can do a better job for a certain application space. It may not be UCIe, and maybe UCIe does have its space at the higher end. But this is where you get started, right?
Yeah, so I think that actually everybody will want to implement their FIs however they want to implement it, right? But at the end of the day, if you can make the framework, the management framework or whatever, or people agree to that, so that, you know, how does the FI come up, what signaling needs to occur, and define it and say, here's a profile that for this market that it could work, and open that up. Maybe that I think this is going to need to be an ongoing discussion, because it's clear that, you know,
I think it's even simpler than that. It's like, instead, when it's a struggle to agree a framework, like for the system management side, if you're doing it anyway for yourself, you say, well, here's how we're doing it. This isn't really part of our value add, but this would be great for, you know. And then somebody says, well, you've missed a bunch of features, and then version 2, you improve the features. But the reality is there is a company that is making a product with what they think is a good system management, because there's nothing out there, and they're prepared to offer it to the community to say, this is step 1 of what we think. And then it's a bit more of a quicker process. And okay, it might not be ideal for everybody, but then just like bunch of wires at the spec level is matured with all of the input of all of you guys, we can actually let's mature it in a physical product rather than just mature it only in specs. In a physical deliverable product, all the way to a product going to a customer, or a prototyping platform, or an emulation platform that's on its journey to a product going to customers.
Yeah, no, I think that there will need to be more thought put into this. There's no question.
For sure.
Yeah, and I think the other point Alan made, which is good, is kind of a more holistic perspective, because we've got Patricia working on HPC modularity, and that is looking at defining a socket and putting chiplets into it. JP's idea currently was a board with these pitchlets in it, but extending that to the next level of, as Quinn suggested, the bridge, or some place where chiplets will fit in, and you can have some kind of interoperability. So I think holistically thinking about it is good. We need to have further discussions on this, and maybe what we need to do is, have separate meetings, though. I know no one wants to hear of an additional meeting, but it might be imperative to maybe squeeze it into existing meetings that the work streams have. But we've got to figure out this direction sooner than later, if we are to be of any use to a community that wants to be part of the chiplet economy, but doesn't have a way of testing, or doesn't have the funds or the ability to do it. So I really appreciate everybody's input, and we'll continue that discussion. Next week, I actually have an agenda already planned, as opposed to a Thursday night email to all of you. So I'm feeling very clever right now. Durgesh Srivastav is going to talk. He's from MIPS, and he's got his list of woes and things that he'd like us to look at and work on, and a lot of it sort of combines with what we've been talking about today. So that should be interesting, but I'll send the agenda out so you guys remember to what's going on for next Friday. On that happy note, thank you all, and off to the next meeting.
Thank
Thanks,
you.
Anu.
Thanks, bye.
Thank you.
Thank you. Bye.